Number 32, we want the exact value of ln e squared over square root e. So we're going to expand. So this is 2 ln e minus 1/2 ln e. Okay, now ln e is equal to 1. So this is equal to 2 minus 1/2, or 4/2 minus 1/2. So we have 3/2. Let me mention another way that we could have done this. All right, let me rewrite this. Ln e squared over square root e. That's equal to ln e squared over ln e squared over e to the 1/2. And now we can just subtract exponents. 2 minus 1/2 is 3/2. So we have ln e to the 3/2. Remember again, log e are exponents, so this is 3/2. In number 33, we solve for x by simply changing this to exponent form. Base to the exponent, that's 2 cubed equal 2x plus 1. So we get this simple equation, x is equal to 2x plus 1. Subtract 1, 2x equals 7, and divide by 2. In number 34, start by bringing this 3 down in front. Use that log property that brings exponents down. And now we can divide both sides by 3. So we have log base 2, 2x plus 1 is equal to 4. And now do what we did before. Write it in exponent form. Base 2 to exponent 4 is equal to 2x plus 1. So this is 16 is equal to 2x plus 1. 2x is equal to 15. X is 15 over 2. In number 35, we want to solve for x. We can't write 5 in terms of base 2, so here we bring down the x by logging both sides. Okay, and now the reason why we did that is so that this x will come down in front. So we have x ln 2 is equal to ln 5, and then x is equal to ln 5 divided by ln 2. And I'm just going to leave it like this. Here we're going to do something similar. Start, though, by solving for 2 to the x. Just divide both sides by 3. So we have 2 to the x is equal to 5 over 3, and now ln both sides. Ln 2 to the x is equal to ln 5/3. Now bring down the x. X ln 2 is equal to ln 5/3. Maybe we should write as ln 5 minus ln 3 using log properties. And now divide both sides by ln 2, and we have x is equal to ln 5 minus ln 3 over ln 2. In 37, we'll ln both sides and bring down the x plus 1 and bring down the x. So we're going to have, we have ln 3x plus 1 is equal to ln 5x. And both of these are coming down. So we have x plus 1 in parentheses times ln 3 is equal to x ln 5. Let's open parentheses here, and so we have x ln 3 plus ln 3 is equal to x ln 5. Now at this point, everything that has x put on one side of the equation and everything without x on the other side. So we'll accomplish this by subtracting x ln 3 from both sides. So ln 3 stays on this side. Here we have x ln 5, and then subtracting this from both sides, we have minus x ln 3. The reason why we did that is because at this point we want to isolate x because we're solving for x, so we're going to factor x out from these terms. So we have here x times ln 5 minus ln 3. The last step is divide by whatever's multiplying x. So that's this. Divide by ln 5 minus ln 3. So we have x is equal to ln 3 divided by ln 5 minus ln 3. Right, 38 is a very similar example. We're basically going to do the same type of thing again. Ln both sides. Bring this down. X ln 2 is equal to x plus 1 ln 5. And now multiply through x ln 5 plus ln 5. Everything with x goes on one side, so I'm going to just subtract this from both sides. So on the left I have x ln 2 minus x ln 5 is equal to ln 5. Factor out x. And finally, we'll get x by itself by dividing by what's multiplying x. So x is equal to ln 5 divided by ln 2 minus ln 5. Right, in 31, we have this 3 in front, but we'll start the same way, ln both sides. So on the left, use a log property right away. Ln of this product, that's ln 3 plus ln 2 to the x is equal to ln 7 to the x plus 1. See, we use the fact that ln AB is ln A plus ln B. We use the first log property right away. All right, let's bring down the exponents. So here we have ln 3 plus x ln 2 is equal to x plus 1 ln 7. Multiply through x ln 7 plus ln 7. And here, let me just copy over ln 3 plus x ln 2. Now we want to organize it. Everything that contains an x on one side, everything without an x on the other side. So I'm going to subtract this from both sides. So I'll have ln 3 plus x ln 2 minus x ln 7 equal ln 7. And now I want to get rid of this, subtract that, bring it to the other side. X ln 2 minus x ln 7 equal ln 7 minus ln 3. So what we accomplished, everything with x on one side, everything without x on the other side. Now factor out that x. And divide by what's multiplying x. That's always the last step. Put that in the denominator. All right, in number 40, we have a log equation that is expanded. If we contract it, we'll be able to solve. So first contract. Use the fact that log a minus log b is equal to log a over b. So we're going to write this as log 5 and the quotient x plus 3 on top, x minus 1 in the denominator. Okay, see, we can expand this and get the line above. Now write this in exponent form. Base 5 to the exponent 1, 5 to the 1 is equal to this. All right, so we have a simple equation. 5 is equal to x plus 3 over x minus 1. Let's write this as a fraction and cross multiply. 5 times x minus 1 is equal to x plus 3, or 5x minus 5 equal x plus 3. Subtract x from both sides. Add 5 to both sides. And finally, just divide by 4. And we get that x is equal to 2. All right, we had one like this before. Start by bringing the exponent down. 2 log 2 x plus 5 equal 8. Divide both sides by 2. log base 2 x plus 5 is equal to 4. Now we're ready to write this in exponent form. Base to the exponent 2 to the 4th equals x plus 5 at 16 is equal to x plus 5. Subtract 5 and x is equal to 11. In number 42, we want to find the vertices of an ellipse. So let's just remember the two standard forms for the equation of an ellipse. So we have x squared over a squared plus y squared over b squared equals 1. And here we're assuming that a is greater than b. Or again, a greater than b. We always assume a greater than b. We might have x squared over b squared plus y squared over a squared is equal to 1. Now, if the larger number is underneath the x squared, that means it's a horizontal ellipse. Major axis is horizontal. And here, the larger numbers under y, it's a vertical ellipse. Major axis is vertical. For both of these, we have the equation c squared is equal to a squared minus b squared. Remember, a is the bigger one. That one comes first. So we have that for both. And c is going to give us the location of the two foci. All right, so let's put this in standard form. So we have 9x squared plus y squared is equal to 81. We want 1 on the right-hand side, so we're going to divide both sides by 81. So here we have 9 over 81. Reduce that, and that would give us a 9 in the denominator, plus y squared over 81 is equal to 1. Now, this is the larger denominator, so this one is a squared, and this one is b squared. So we have a is 9, and we have b is 3. So this is a vertical because the larger number is underneath y. So let's draw the ellipse, although we don't have to for this problem. It's just sort of easier to visualize things. I'm drawing a vertical ellipse, and an ellipse of this form is centered at 0. This is 0 over here. Okay, so a is 9. That means this distance along the major axis is 9. So this point here is 0, 9, and underneath this is 0, minus 9. The vertices are the high and low points. If we're talking about a vertical ellipse, the high point and the low point. So these are the vertices, the two pointed ends, let's call them, of the ellipse. So these are the vertices, and that's all we had to find here with the vertices. Okay, 0, 9, and 0, minus 9. Let's say we were asked to find the foci as well. Then we would use this little equation over here. All right, so c squared equal a squared minus b squared, just to figure out c squared. So that would be 81 minus 9. All right, or 72. So c is square root 72. So this focus up here is 0, square root 72. And this one is 0, minus square root 72. In number 43, we want to find the foci of the hyperbola. So let's just recall the two forms of an equation of a hyperbola centered at 0, 0. So first we have x squared over a squared minus y squared over b squared is equal to 1. And this one is a hyperbola that opens right, left. This is 0. And this is a0, and this is minus a0. or we could have y squared over b squared minus x squared over a squared is equal to 1. And this is a hyperbola that's up down. Okay, this is 0. This is 0b and 0 minus b. And the foci would be located here and here. And they would be C over from these are called the two vertices. These would be vertices. So this one would be A plus C. And this one is minus A minus C. All right, and this one is 0B plus C. And this one is 0 minus B minus C. And then we have an equation relating A, B, and C, and it's C squared is equal to A squared plus B squared. All right, so ours is of this form because the x squared term comes first. And so in our case, A squared is equal to 16. And B squared is equal to 4. So we have that A is equal to 4. And we have B is equal to 2. So C squared is equal to A squared 16 plus B squared 4. That's equal to 20. And C is square root 20. And so our foci are located at A plus C. A is 4 plus square root of 20, and minus 4 minus square root of 20.